Hi, everybody. This is Mr. Endres coming in to give you kind of a short video tutorial on some of the homework problems and concepts from Thursday, June 18th homework on slope and slope-intercept form practice. I wanted to go over just some basic ideas and things that Mrs. Murray and I see from the homework, and just wanted to let you know how to do some of the problems. So I'm going to go through just a handful of each type of problem and just kind of tell you how I would approach a problem. So I'm going to look at number one. So it says find the slope of the line. So I'm going to start by identifying, I'm using a stylus here, so I apologize if it's not the most clear. I'm going to identify first 2 points that I know are on my line. And then from there, calculate slope. So I know I have points that are there and there. And what I want to do is, I'm a more visual person, so I'd like to calculate how much rise is going on, how much run is going on. So if I calculate my rise, I count how many grids go up. I'm going to say 1, 2, 3, 4, 5, 6, 7, all the way to up there. So up 7. And this one goes over 1 and 2. So rise is the vertical side of 7, and run is 2. So I know my slope is 7/2. It's a ratio, rise over run. Same thing with negative slope, or lines that have negative slope. I could calculate the slope from 2 points. So like this one, I could calculate this one went down 2, and it went over 1, 2, 4, 5. So it went down 2 in the negative direction, over 5. So my slope would be -2 fifths. If you don't remember the slope formula, here it is. This is slope. Rise over run. The next set of problems, I'll go down here first. Next set of problems, find the slope of a line through each pair of points. I'm going to do 2 of them. I'm going to do 7 and I'm going to do 8. So 7, rise over run. So slope can also be written as y2 minus y1 over x2 minus x1. So if I calculate the change in y, I have 7 minus 1, which got me 6. And I got the run, which was 17 minus 16, which is 1. So my slope is 6, or 6 over 1. Same thing for this one, but check this out. Change in y, 8 minus 8 gets me 0. 7 minus 2 gets me 5. 0 divided by any number is always the number 0. And this would actually be the slope for a horizontal line. Find the slope and y-intercept of each equation. Your equation, before you evaluate the slope and the y-intercept, always has to be in the form y equals mx plus b. So when I do that, like if I start, I'll do 11 and I'll do 15. I have to move this 3 over by subtracting 3 to get y by itself. So I have y equals x minus 3. Now, if there's no number in front of x, which is where your slope number would be, this is slope, I would say m here is equal to 1. So slope of 1 goes up 1 over 1, and your y-intercept is at -3. So it goes through the y-intercept, the y-axis at -3. The next one, 6 minus 2y minus x, I'm going to have to move the 6 over. So I get -2y equals -6 minus x, and then I'm going to divide everything by -2. I'll bring this one over here. I get y equals 3 plus 1/2 x, or x over 2. because the x was divided by 2, that means the fraction 1/2. So my slope is 1/2, up 1 over 2. My y-intercept is 3. Write an equation of a line in slope-intercept form. I'm still going to use y equals mx plus b. I'll do 17 and 20. So for this one, the y-intercept touches here at -1, and I need to calculate its slope, so I'll do that in a different color. You could do y2 minus y1 over x2 minus x1. I'm just going to visually do it, so I'm going to say it goes up 1, 2, 3, 4. It goes over 1, 2, 3. So my slope is 3/4. My y-intercept is -1. So my final equation is y equals 3/4 x minus 1. Number 20, if it's a horizontal line, your equation will always be y equals some number, and that some number is your y-intercept. Because this line is flat, it has no slope. It has no rise to it. So there really can't be a number in front of x because x won't happen here. And if this guy, let's see here, goes through 1, 2, 3, -3, y equals -3 is your final answer. Horizontal line. Very important that you know about that special case line. Let's see here. I could do one of these for fun. Let's do 23. Y equals -2x plus 2. So m was -2. That's my slope. Down 2 over 1. My y-intercept is 2. So I always put a dot at the y-intercept first. Okay? And I'm just going to make a trail of dots. So this one goes down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. A horizontal line case, like in number 34, I'm just skipping around here, but I just want to make sure you know some crucial ones. Y equals 4, I'm just going to put a dot at 4, and I remember that if there's no x term, and if it's just y equals a number, that is code for a horizontal line. I'm going to put a horizontal line at 4. Let's see, what else? Let's do one of these. Write in slope-intercept form of a line, given the slope and y-intercept. So this is just following y equals mx plus b. Pretty straightforward. They give you m and they give you b. So 36, this is m, so I write y equals 5x, and the y-intercept is 2, so I write plus 2. 37 and 38 are probably the most challenging of this homework. It says write an equation of the line mx plus b if you're just given 2 points. So the first step is to find slope. And you're going to use slope is y2 minus y1 over x2 minus x1. So if I plug in what I know, I have 4 minus 0 divided by -4 minus -5. And I get 4, and this turns into -4 minus -5 is -4 plus 5, which is 1. That makes a really nice slope number. 4 is my slope. For the b value, you're going to have to use one of these coordinates. I'm just going to choose the first one and plug it into y equals mx plus b and solve for b. Let's do this in a different color. So I have y equals mx plus b. I'm going to plug in 0 for y, slope is 4, the x value is -5 plus b, and then I get 0 equals -20 plus b. If I add 20 to both sides, 20 is b, my y-intercept, which is good. That means it crosses the y-axis at 20. My final equation is y equals 4x plus 20. You will have to do this process for every problem. So step 1, solve for slope. Step 2, solve for y-intercept and plug it in your equation in step 3. This is just, again, a video just to go through a couple examples. Please reach out to us when you have questions, and we're happy to help.